Twistronics is an emerging subfield within quantum technology. It concerns the stacking of two-dimensional materials to obtain desired electromagnetic, photoluminescent, and other properties. These properties will pave the way for lossless communication systems and faster data transmission. The 2D materials required for twistronics are currently expensive to fabricate. They consist of a single atom or molecule layer thick of a desired material, including graphene, a single layer of graphite, and transition metal dichalcogenides, or TMDs for short. Our sponsor, Dr. Carlos Torres at the Naval Information Warfare Center Pacific, is especially interested in TMDs due to their tunable bandgap at their 2D level. The purpose of this project was to develop a reproducible method to cost-effectively fabricate 2D samples of TMDs for the purpose of research. The following video presents the fabrication process of 2D materials through mechanical exfoliation along with the adjustable parameters. Other methods have been developed to create large monolayered materials. However, as is the case with chemical vapor deposition, the 2D material fabricated is polycrystalline, with many grain boundaries influencing the material's quantum properties. Therefore, this project focused on the cost-effective method of mechanical exfoliation, capable of creating monocrystalline flakes within the specifications of our sponsor's request. First, a desired material is bought in its bulk flake form. A tiny piece is transferred onto a selected piece of tape. To mechanically exfoliate, the tape is pressed and peeled apart a tunable number of times, causing the tape to look cloudy with thinned flakes. Next, an oxidized silicon substrate is cleaned either by baths of acetone, IPA, and deionized water, or by oxygen plasma treatment. The substrate is then placed onto the tape, oxidized side down, and gently pressed together with tweezers. Optionally, the tape and substrate can be temperature treated in an oven, hot plate, freezer, or other method at adjustable temperatures and times to promote adhesion and flake transfer. Once prepared, the tape is slowly peeled off of the substrate. After this step, it is important to keep the substrate clean and undamaged, as there are now thousands of flakes of varying size and shape on the substrate. The yellow sections reflected off the substrate are the successfully transferred flakes. Under a microscope, the flakes are easily identifiable. However, none shown here are two-dimensional. The specific method developed has been successful in creating substantially large flakes in surface area, yet they are still multi-layered. The next steps for this project to continue is to experiment with polydimethylsiloxane materials to precisely manipulate individual flakes, further exfoliating and later extracting 2D samples.